Okay, ladies and gentlemen, welcome back to Mr. Lee Physics class. So today we start with the application of the electron. So ladies and gentlemen, let's say we have a positive charge. We have a charge, where a charge with a potential difference. So the positive charge is released, then through a potential difference, that means that one is a terminal positive, another side is a positive is a terminal negative. That means that the positive charge will accelerate to the negative terminal. After that, the electron is released into the uniform magnetic field. So we notice that, as we know that the electron will deflect. The motion of the electron is in a curved motion, where how to make sure the electron reach to the target. When the charge reach to the target, where it will be neutralized, that means that it will flow to the earth. At the end, where it flows through the another micro emitter, so that if current flow through or charge flow through, will produce a current. So now we look at here. Here we have a uniform magnetic field, high voltage supply, normally more than 1000 kilowatt. And then here will be, once the electron release from positive terminal to negative terminal, it will produce the positive ion beam. Here will be the collector for the positive ion. So microemitter and earth. Now we notice that once I release with 0 kilowatt, so that means that the positive ion will not move anymore. So when the ion with 1000 watt or 1 kilowatt, what happened? So we notice that the electron is accelerated, but the magnetic force produced. The electromagnetic force produced cause the ion hit to the wall of the maybe you can say that there is a tube, there is a way. So that means that it will hit the wall. Then what happens if I increase to 2 kilowatt? If 2 kilowatt, that means that the motion path will be the perfect way. That means that the ion successfully reach to the other side of the collector and produce the current. If the potential difference is higher, what happens? That means it will hit to the other side wall. Highest, that means that still hit the wall. So that means that in this case, what is the purpose? That means that we want to find out the most suitable potential difference, which supply to the positive ion, so that it will move in the channel to reach to the target and flow to the earth. Okay, next. So still the same thing. From here, how about when the electron move, as we know that the perfect potential difference will be 2 kilowatt, 2000 watt. So how is the calculation? Let's say if the mass of M is the mass of the ion, B will be the magnetic flux density, and V will be the accelerating voltage when the ions are collected by the collector, and Q will be the charge of ion. Velocity of the ion beam in the magnetic field is 1/2 mv squared, m will be the mass of the ion, yeah, will be equal to qv. That means that the kinetic energy of the ion in the magnetic field, in the magnetic field, is equal to the qv. qv is the electric energy. This means the energy provided from the electric, 2 kilowatt. So from here, V, the speed of the positive ion is equal to square root of 2q V. V will be the potential difference here, the big V. 2qV over M. So in the uniform magnetic field, mv squared over R, that is the centripetal force of the positive ion in the curved motion. In the circular motion is equal to qBV, the electromagnetic force. So as a result, we found that mv is equal to qBr, and m2v2 is equal to q2b, m squared v squared is equal to q squared b squared r squared. So this means that m squared times with v squared will be equal to 2qv over m. This formula is from this formula. And q2, q squared, b squared, r squared, where r is equal to the d divided by 2. D divided by 2, we notice that where is the d? Okay, this will be the d. Diameter divided by 2 will be the radius. So at the end, we get that m will be equal to q b squared over 2v times with d over 2 squared. So this is the formula. This is the method we use to determine the mass of the ion. So ion, we don't know how to, we cannot use, what I said, we cannot use the measuring meter. We cannot use balance to measure. So we just can use the magnetic field and the electric potential to make sure to determine the mass of the ion. Observe the next slide. So same thing, same apparatus. Now, when the apparatus is provided with 0.5